All right, so I want to begin this practice test and run through every solution so that we feel completely comfortable. So we're going to answer the questions about each graph slowly, carefully, and make sure we go through everything. So first, question number 1 asks, which object is going faster, A or B? And the answer is A. And just to be clear, it's because the slope of this graph is steeper. That's how we can tell. Now, the way we're going to really show this is by getting the velocity of each object. And to do that, we're going to calculate the slope of each line that represents the motion of the object. So for graph A, I'm going to pick 2 points on graph A. And in fact, I'm going to just color code this a little bit. So I'll choose this point here and this point here. So on this graph, it's at 0 seconds, and we start at a position of 9 centimeters. And then our second point, after 4 seconds, the object ends up at the 5 centimeter mark. So to get the velocity of the object A, we're going to do the rise over the run, which is going to be 5 minus 9 over 4 minus 0. And that's going to end up being negative 4 over 4, which is negative 1 centimeters per second. Now let's go ahead and take a look at object B. I'll use a different color for object B. So we'll use this point here, 0 seconds, and we're at the origin. And here at 6 seconds, or at 8 seconds, it appears that I am at the 4 centimeter mark. So for B, using the rise over run calculation, that's going to be 8 minus, 4 minus 0, because it's the y, the vertical, the position coordinate, over 8 minus 0. That's going to give us 4 over 8, which is going to give us 0.5 meters per second. So even though this is negative, its absolute value is bigger than the absolute value of VB, and that's how we know it's going faster. Now, to get the displacement of the object after 2 seconds of each object, let's be careful here. So the displacement of object A, so what we do is we go up to the 2 centimeter mark, and we notice that its coordinate is 7. Its position coordinate is 7. And it started at 9. And if we actually use our definition of displacement, that's going to be x final minus x initial. That's going to be 7 minus 9 from the graph. Reading these points here, 7 minus 9, and that's going to give us negative 2 centimeters. Similarly for object B, we'll do a calculation. So we'll get the displacement of B is going to be its x final minus its x initial. So it started here, and at 2 seconds it's here. So it's at the 1 coordinate. So that'll be 1 minus 0, and that's just 1 centimeter. Now, if we plot the velocity of the graph below, the velocity, what that means is we're simply going to plot the slope of each object's line, because the slope of the position graph is the velocity graph. In fact, please remember that fact. The slope of position is the velocity. That's one of those fundamental facts that we absolutely need to know. So, if I'm going to plot the slope of graph A, that's a slope of negative 1. So I'll actually plot this line right across here over the 10-second period. And for graph B, I have a slope of 0.5. I'm going to remove these absolute value signs. I think they're a little confusing to people if they're looking at this later on. So that will be negative 0.5. Let me make sure I have that. Positive 0.5. And so I'll go here to the 0.5 mark. Make sure I get that highlighted correctly. And I will draw this line about halfway across here. So that's object B, 0.5 meters per second. And again, object A is at negative 1 meters per second. So there we go. All right, so that's problem number 1. And in the next video, we'll take a look at problem number 2.